Good day, I'm Alvarez, and for today's video we are going to create half subtractor and full subtractor. Half subtractor, before we design the circuit, we need to know first the truth table, which we are going to go and create this equation, which the D would be the difference and B would be the borrow. But when D is equals to x minus y, if x is equals to 0 and y is equals to 1, t is equals to 0 minus 1, which is equals -1. But in logic gates, when the greater value is subtracted from smaller, the smaller one need to take borrow. Then in such case, borrow will be 1. So the equation would be d is equals to x prime y plus x y prime b is equals to x prime y. So now let's start to create the circuit. So first, we are going to need two input pins that is facing at the east. Then two of this one of this, no, two of this one, and connect this. After connecting the NOT gate and the input pins, we are going to need the AND gate, which will have two inputs, two number of inputs. Connecting these two. So after we connect this, we are going to need another NOT gate. Another NOT gate that would be connected to the other input pin and should connect this to. We should connect this to. So after connecting that to, we are going to need another AND gate that will be having another two inputs and will be connected to this and into this one. So as you can see, we are halfway done with our circuit. Then, of course, we need to have two outputs in order for us to know if the circuit is properly working. And this will show the results of the D and B, which is the difference and the borrow. After this, we are going to need the OR gate, with two input pins as well. No, not that one. It's the data bits. So we should connect this first. Then after connecting those two, we have to connect this too. So that would be the circuit, but first we need to label it so that we know which is the x and the y and the difference in the borrow. So leave it here. X, y, b is going to be the borrow, then d. So as you can see, we have created the half subtractor. So let's check if it's properly working. So let's try to input 1. So if we input 1 on the half subtractor, the answer or the output should be ones. 1. See? 0, 1. And after checking this, let's try to input 0, 1, which is going to be 1 as well, but we'll have the same output. Then if we subtract like 0, 0, 0, 0 or 1, 1, the output should be 0. So the circuit that we have done is properly working as a half subtractor. So after this one, we are going to create the full subtractor. The full subtractor. So in creating the full subtractor, we also need a truth table. So in creating the truth table, or getting the truth table, we have created the proper equations to create our circuit. So here we have 3 inputs, which is x, y, z, and 2 outputs, which is d and b, which is the difference and the borrow. Now the formula for the difference will be d is equals to x minus y minus a. So according to the truth table, d columns containing ones. So the equation will be d is equals to x prime y prime z plus x prime y z prime plus x plus plus x y prime z prime plus x y z. So if we are going to simplify it, the difference in the borrow, this will be the answer. And the borrow would be x is equals to x prime y plus x prime z plus yz. So after we have properly solved the equation in creating the circuit, we are going to proceed in creating the circuit for the full subtractor. So we are going to need 3 input pins, 1 NOT gate facing south, and we are going to need an XOR gate having 2 inputs. We are going to need two of these ones, this XOR gate with 2 inputs. So first we need to connect this one into this one, then this one into this one. So after this, we are going to connect this into the other input, then proceed with the another XOR gate that will be having two inputs as well. So here you go. After this, we are going to need an output pin to see if it is properly working. So, and we are going to know the output of the circuit that we had made. So after this, we are going to label this as X. X. So let's proceed to Y. So in Y, we are going to need an AND gate, two input pins, another AND gate with two input pins as well. So after this, we are going to connect this one into this, then this one into this. So after this one, we are going to need an OR gate with two input pins as well. Actually, all the gates that we are going to use will be having two inputs only. So here, now after this, we are going to need another AND gate with two input pins as well. And a OR gate. Let's just adjust this to have some space. Let's just double check if it's properly connected into each other. There you go. We forget something, which is the other output. So here you go. Here is the circuit of a full subtractor. So let's test it if it's properly working. So if you input 0, 0, 0, it should be 0, 0, 0. And when you input 1, 0, 0, the borrow should be 1. And inputting 0, 1, 0, the output should indicate that the borrow and the difference would be 1, indicating the answer is 1. So in inputting 1, 1, 0, the answer should be 0. And 1, 0, 1, the answer should be 0 as well. So after this, we have completely or properly created a half subtractor and a full subtractor acting or doing its job as a subtractor. That's all. Thank you.